Mathematics, as you know, is an area of science that deals with calculations, theorems, geometry, etc. and is applied by engineers in the construction of structures such as bridges, buildings, monuments, and the like. However, it will be interesting and indeed surprising to note that mathematics in its seeming boring complexity has been used to discuss a simple and exciting phenomenon: birthdays. Although the earlier version of the birthday paradox or birthday problem was proposed by a 19th century scientist and mathematician by the name of Richard von Mises, it was first discussed by Harold Davenport. This paradox states that in a random group of 23 people, there is a 50% chance that two people have the same birthday. Fascinating, right? But now, the question is it true? Well, come to think of it. If you try to compare your birthday to that of the other 22 persons in the group, it is less likely to find your birthday mate because you just have 22 pairs of birthdays. But when you compare each person's birthday against the other birthdays, you get 253 pairs, thereby increasing the likelihood of getting a pair of coinciding birthdays exponentially. Now, of course, that is true. The theory goes on to say that when the number of randomly chosen people is increased to 70 or more, there is a 99.9% chance of obtaining coinciding birthdays. You might be wondering why it is a 99.9% chance. The more number of people, the more combinations will be available and higher the possibility of getting a matching pair of birthdays. There are 365 days in a year, so if there are 367 people in the group, the number of people are more than the number of birthdays. That is, one birthday for every day of the year and 2 extra. So the probability of obtaining a matching pair of birthday is 100% in this case. But any figure below 365 people reduces the possibility. There's a formula that goes with the theory, and it's used to calculate the probability percentage of obtaining coinciding birthdays. The formula as explained does: D represents total number of days in a year, which is 365. N is number of combinations, that is, the possible number of pairs obtainable. For example, the nth combination of 23, but it can be easily derived from the formula where P equals the number of people. As you know in maths, the probability of something to occur equals 1 minus the probability that it won't occur. From the equation, this represents the probability that everyone has separate birthdays, and thus no 2 people or more can share the same birthday. While putting the theory to the test, I obtained a list of 23 randomly picked Hollywood stars from the IMDb website, and as postulated by the theory, I got 2 people, Will Smith and Catherine Zeta-Jones, with matching birthdays. I also got a list of 23 randomly picked musicians and compared their birthdays. I didn't get any matching birthdays. I further tested this theory with a list of 72 randomly picked personalities, including the Hollywood stars and musicians, and I got 7 pairs of matching birthdays, including myself and Catherine Hale. Now, in the case of the first list, I got only a pair, while there was none in the second list. This proves the theory that there is a 50% chance in a random group of 23 people of obtaining at least a pair of coinciding birthdays. This also means, therefore, that there is a 50% chance of not getting any pair as observed in the second list. From the list of 72 people, we see that the number of pairs increased to 7. This means that the chances were increased and hence supports the theory also. Now that we've been through the birthday paradox, we can see that we can actually make our birthdays and the birthdays of others more fun by simple calculations and comparisons. Well, it's up to you to make someone's birthday a whole lot brighter. But in the meantime, I have to run because I have some birthday problems to solve. See you around.